Okay, we will see the exemplar questions in the redox reactions. Before going through the questions, I will show you some information. Um, Electronegativity of the various elements, okay, in the periodic table. Uh, from from this you can see fluorine has the highest electronegativity. So you can remember the electronegativity at some of the important elements here. Also, they remember these metals and non-metals, because hydrogen in combination with non-metals, hydrogen will have the oxidation number of positive 1, and hydrogen with the metals, the oxidation number will be negative 1 for the hydrogen. Okay, now how to find the oxidation number? Okay, that is given in your the NCERT book. There are rules on how to find the oxidation number for the pure element, for the ionic element and the compound. Fluorine has the highest electronegativity. So you can go through these 6 rules in your book. Okay. Now I will show you that rules with some examples. Okay. Now for the rule 1, pure element, then the oxidation number will be 0. Example like zinc 0, and this H2 0, sodium 0, 4 Cl2, all 0, pure element. Rule number 2 for the ions, the single atom, let us see Fe plus 3, that it means oxidation number will be positive 3. Cl minus, oxidation number will be negative 1. O2 minus, oxidation number will be the minus 2, that is the charge. But for diatomic like this, He2 plus 2 charge, so charge divided by 2, there are 2 atoms, so it is positive 1 oxidation number. Similarly, O2 minus 2, minus 2 divided by 2 is minus 1. Okay, now for the oxygen, the oxidation number will be negative 2 in most of the compounds. Example here, PO4 2 minus P plus 4O equal to this charge, that is negative 3. So here where oxygen is minus 2. So 4 into minus 2 minus 8. P minus 8 equal to minus 3. P equal to positive 5. But in this compound OF2, here oxygen will have positive 2, because fluorine is more electronegative than the oxygen. So fluorine, we have to use the oxidation number of fluorine here, that is negative 1. So 2 into 1, oxygen, then minus 2 equal to 0. Oxygen equal to positive. So here oxygen is positive 2. Here we are using negative 2. Okay. Now we will show you the other rules. So here, as I said, hydrogen compound with non-metals, it will be positive 1. For metals, it will be negative 1. So example here, NaH, hydrogen oxidation number is negative 1. HCl, it will be plus 1. Okay, like this here. So HCl, in HCl, hydrogen will have a positive charge, but in NaH, hydrogen is a negative charge. So depends on the electronegativity. Now in the compounds, let's say MgCl2, Mg plus 2Cl equal to 0. If we substitute minus 1 for the Cl, then Mg you will get positive 2. So here SO4 minus 2, S plus 4O equal to negative 2. For oxygen, if you substitute negative 2, then you will get the positive 6 for the sulfur. Okay. Here, so the oxidation number can also be a fractional like this. In Fe3O4, 3Fe plus 4O equal to 0, and you substitute, then Fe will be 8 by 3. That means 3Fe, or not all Fe atoms have the same oxidation number. So it can be 332. Okay. As I said, fluorine always a negative one. So in this compound, AlF3, you substitute negative one for the fluorine, then Al will have the oxidation number of positive 3. Okay. Now let us take some more examples how we will find the oxidation number. In this case, H2S, see here, this is the hydrogen, sulfur, hmm, and oxygen. See electronegativity 2.1 for the hydrogen, sulfur 2.5. So as compared to hydrogen, sulfur is more electronegative, but as compared to oxygen, sulfur is less electronegative. So now we have to use that. So here we are substituting plus 1. So sulfur here will have the negative 2 as the oxidation number. But in this case, you see sulfur having partial positive charge, this will have partial negative charge, because here oxygen is more electronegative than this sulfur. So here if you see positive 4, so the same element sulfur will have the different oxidation number depending on the compound. Okay. Now one more thing I want to show you, in the reduction potential, copper 2 plus plus accepting 2 electrons yielding copper, radiation potential 0.34 volt means if you write the reverse reaction, that is ulta, Cu equal to copper 2 plus 12, then this radiation potential will be the sign of this radiation potential will get reversed. So positive 0.34 will become negative 0.34. Okay. Now I'll show you the how you balance the redox reactions. Okay, from the book. I'll show you that example in the book. There are two methods. One is the oxidation number method, and other is the off reaction method. Okay, so I'll show you examples in the two methods. Oxidation number method. So now we'll take this example first. Okay. Write the net ionic equation for the reaction of potassium dichromate with the sodium sulfate in an acidic solution. That is important. This is acidic solution. Okay, here you'll see how to balance the equation in the acidic solution. So first you have to write the skeleton equation like this. Then you have to assign the oxidation number. So how do you find the oxidation number of chromium? So you have to use that rules which I mentioned. So here if you say for the oxidation they use the negative 2. So 14. 2Cr minus 14 equal to minus 2, 2Cr equal to plus 12. Okay, then Cr will have positive 6. Same is sulfur. So here sulfur oxidation number is increased plus 4 to plus 6. That is, it is oxidized. Sulfur is oxidized and chromium is reduced plus 6 to plus 3. Okay. Dichromate ion is oxidant. Oxidant means it is reduced, and the sulfate ion is the redundant, that is oxidized. Now we calculate the increase and decrease in the oxidation number of the and make them equal to from this step 2. We can notice that there is a change in the oxidation state of chromium and sulfur. Oxidation state of chromium changes to plus 6 to plus 3. There is a decrease also, it is reduced 3. Then oxidation of the chromium on the right hand side of sulfur changes from positive, that is sulfur is increased oxidation state. To make increase and decrease of oxidation state equal, place 2 before the chromium ion on the right hand side and the numerical 3 on the right hand side. Okay, so now they balanced this equation in terms of the atoms. So now we have to balance the charges. As the reaction occurs in the acidic medium, further the ionic charges are not equal on the both sides. So acidic medium means you have to add H plus ion to make the ionic charges equal. So they added the 8H plus ion here. Okay. So already we have 6 electrons. So for negative charges here, 3 into 2 and there is a 2. Okay. Here 6, so 8 electron. Then 8 negative charges. So 8 positive charges they put to balance it. Okay, now finally count the hydrogen atoms and add the appropriate number of the water molecules. So here acidic medium means you have to use H plus and water molecules. So this is the balanced equation. Now in the basic medium you will see the example in the basic medium. Okay, here. So here in this example permanganate ion reacts with the bromide ion in the basic medium. So here we have to OH minus ions we have to use. There H plus plus water, here OH minus. So first you have to write the equation, then you have to balance it. Okay. Assign the oxidation number, then balance it. Calculate the increase and decreasing. Then as the reaction occurs in the basic medium and the ionic charges are not equal on both sides, add OH minus ions on the right to make the ionic charges equal. So here it is balanced. So now the finally count the hydrogen atoms and add appropriate number of water molecules on the left side to have the balanced redox reaction. So this is in the oxidation number method. So we will see one example in the off reaction method also. So this is that example. Permanganate ion in the basic solution oxidizes iodine to produce molecular iodine molecule and manganese oxide. Write the balanced ionization to represent the redox reaction. Okay. First you have to write the equation. Then you have to divide, split into oxidation part and the reduction part. Then they balance the iodine ions. Then balance the oxygen atoms with the water molecule here. To balance the hydrogen atoms, we add 4H plus ions to the left. Okay. So here 4H plus ions, here these 4 hydrogen, so 4H plus ions. As the reaction takes place in the basic solution, therefore 4H plus ions are add 4 OH minus ion on both sides of the equation. So now this H plus and OH minus will combine and become water. So there will be 4 H2O molecule here, right side 2 H2O molecules. So 2 cancel out, then net left side 2 H2O will be there. So this is the final equation. Now we have to balance the charges. Okay. So now a 2 electron right side we have 2 electron, left side 3 electron. 2 and 3 there is a LCM 6. So make it 6 electron. Then cancel out the electrons on the left side and the right side. Now add then the final verification of the atoms and the charges. Okay. Okay, they will see these multiple choice questions. Which of the following is not an example of a redox reaction? Okay, so now this is the first reaction. Here hydrogen is undergoing oxidation because its oxidation number is increased from 0 to positive 1. Then copper is undergoing the reduction. So there is a oxidation reduction takes place in this reaction. Oxidation of hydrogen, the hydrogen is a reducing agent. Similarly, reduction of copper, copper is the oxidation agent. Okay. Similarly, the other reaction. But if you see this reaction here, see this oxidation number is not changed. Chlorine, hydrogen, sulfur. Okay, so this reaction is not a redox reaction. So the answer is this. This is the correct answer. No oxidation reduction takes place. more positive values of the electrode potential, the greater the tendency of the species to get reduced. Okay, this is given in the book also. Using the standard electrode potential of the redox couples given, find out which of the following is strongest oxidizing agent. See, oxidizing agent is same as the reducer. So the element which gets reduced is the oxidizing agent. So they are given already greater the intensity of the more positive means greater tendency to get reduced. So that is the strongest oxidizing agent. So they given the value, this Ag is the strongest oxidizing agent get reduced. These electrode potential values of the redox couples are given below. On the basis of these values, choose the correct option. See here they are already given. More positive means greater the tendency to get reduced. So this is more positive in the order. First beer, this couple, redox couple will come first. Then this will come the last, copper. Okay, so the copper will reduce the beer too. Using the standard electrode potential, find out the pair between which reaction that is not possible. They are asking which is not possible. Okay, so so these are the reactions. If you oxidation, this is the reduction part and this is oxidation part. You add up the all these things are coming positive. They are asking which is not possible. So this combination, this is the oxidation and this is the reduction. If you add up these two potential, you get a negative value. So this is not possible. So this reaction is not possible. So this is the answer. Thiosulfate reacts differently with iodine and bromine, and the reaction is given below. So here you have to see the electronegativity. Sulfur, see this is the bromine, iodine and sulfur. The iodine and sulfur they are almost same electronegativity, but bromine has the higher electronegativity. So bromine is the stronger oxidant than the iodine. Okay, this is the correct answer. Oxidation number of an element in a compound is evaluated on the basis of the certain rules, such I already showed you in the book 6 rules. Which of the following is not correct? So the oxidation number of the hydrogen is positive one. This is not fixed. Only with the non-metal it is positive one, but with the metal is a negative one. Okay, that is also given in the book 6. See here, the oxidation number of the hydrogen positive one will only with the non-metals. Okay. Which of the following compounds have different exhibits two different oxidation states? So here nitrogen in this ionic compound, so it will be -3 and NO3 minus it is +5. So here we have two different oxidation number for the nitrogen. So this is the correct answer. Which of the following arrangements represent the increasing order of the oxidation number? So you have to find out the oxidation number of the each compound and then write. So each compound CrO2 minus Cr plus oxygen minus 2, 2 into minus 2 equal to this -1. Cr minus 4 equal to negative, Cr equal to +3. Similarly, you have to find out this. Then increasing order will be this 3, 5, 6, 7. So this is the correct answer. The largest oxygen number exhibited by the element depends on the outer electronic configuration. Okay. With which of the following outer electronic configuration will exhibit largest oxidation? Obviously, more electrons here. So this is the answer. Identify the disproportionate reaction. That is, the same element will have two different oxidation states in the reaction. Okay, in 11. So this is that reaction. Okay, this reaction they are given. So here it involves disposition of this because of these different oxidation states. So you can go through the book here. Which of the following element does not show disproportionate intensity? Because the fluorine has the highest electronegativity, it has only one oxidation state. F has the highest electronegativity and it cannot lose electrons. So the only one oxidation state, that is my negative one. Okay, which of the following statements are not true about the decomposition reaction? Okay, 12. Okay, this is the reaction. So you have to find out the oxidation number. So K is unchanged. Oxygen -2 to 0, that is getting oxidized. Chlorine getting reduced. Okay. So this is the potassium is unchanged, and here oxygen is getting oxidized and chlorine getting reduced. So these two are not true. Okay, it is undergoing oxidation they are given, but it's actually unchanged. Identify the correct statement in the following. Okay, in this reaction, 13. Okay, zinc plus HCl. So zinc oxidized, hydrogen reduced, Cl unchanged. Zinc oxidized, hydrogen reduced. Oxidation means is redundant. Okay, reduce. So these two are the correct answer. The exhibition of various oxidation by an element is also related to the outer round electron. See, I have underlining these important points in this question. So this is underlined. Okay. Atoms having which of the following outermost electronic configuration will exhibit more than one oxidation states. Okay, here the only one oxidation. These elements will have a different oxidation states. 15. Identify the correct statement in the reference to the given reaction. Okay, here these two are the correct. So this is that reaction. So the phosphorus have two different oxidation states in this. Okay, so you can see this reaction here. So phosphorus is undergoing oxidation as well as reduction. Hydrogen is undergoing neither oxidation or these are the correct answers. Which of the following electrode will act as anodes when connected to the standard hydrogen electrode? Okay, so The stronger reducing agent will act as anode. That is more negative will act as the anode. 17. See this they are given here. Okay. Anode means where electron is released. Short answer type. The reactions represent the process of bleaching. Identify and name the species that bleaches the substances due to its oxidizing action. Okay, that is the. So here, if you see in the book, hmm, the reactions. Okay, this reaction describe the formation of the household bleaching agents. Okay, so this is the reaction for the formation of the bleaching agent. Okay, MnO4 humans undergoes disproportionate reaction in acidic medium, but MnO4 does not give the reactions. So, okay, I'll show the answer. Okay, MnO4, Mn is the highest oxidation state. Okay, above that it can't be oxidized. That is +7 because this O -2. So Mn plus -8 equal to -1. Then Mn is in the +7 oxidation state. Therefore, it does not undergo disproportionation. Okay, but here it undergoes a disproportionation reaction as follows. So here the thing is that it's already in the highest oxidation state. Okay, you can refer to this problem also 8.5. Okay, so the which of the following species do not satisfy? So you can read go through it. This is the main thing is the highest oxidation state. PbO and PbO3 reacts with the HCl according to the following chemical reactions. Okay. Why do these compounds differ in their reactivity? Why these two reactions are different? Mm, okay, these two reactions, this is a redox reaction, that is oxidation reduction takes place. This is acid-base reaction. 19. Oxidation numbers of the lead. Which 2 sulfur 12. 12, 8.7. Okay, so you can go through this problem. This is similar thing. Okay, so here you can go through what is the oxidation state, why they do differ. Nitric acid is an oxidizing agent and reacts with the O, but it does not react with this. Explain why. 20. U is a base oxide and a simple acid-base reaction takes place between EVO and HNO2. On the other hand, EVO2 is lead is in the plus. This here also this oxidation number will come into the picture. and cannot be oxidized further. So that is in the highest oxidation state. Therefore, no reaction takes place. Okay. So 28.7. So here you see itself is an oxidation, therefore it unlikely that reaction may occur. Okay, you can go through this problem. 8.7. So write the balanced chemical equation for the following reactions. This is the ion electron method, means this is off reaction method. This is oxidation number. This is also ion reaction method. So I will show you that equations. As I already explained the oxidation number method and the off reaction method, you can go through the book and try to solve yourself. Okay. Now this is the that equation. Ion electron method, oxidation method, and ion electron method. This is the final equation, balanced equation. So you can write down this equation and you can try yourself using that book example. The acidic medium, this is a basic medium. Calculate the oxidation number of the phosphorus in the following 22. Okay, here on the hydrogen 1, phosphorus, oxygen negative 2, so it is positive 3, here positive 5. Calculate the oxidation number of the each sulfur atom in the following. So you have to use the Lewis structure to find out this. Okay. So this is these oxidation numbers. Then there is a description is given in this. Okay, you can go through it using these Lewis structures. This is in the exemplar answers. Okay. So balance the following the oxidation number. You can go through that book solved problem of oxidation number method balancing the redox equation and you try to solve yourself. Okay. Identify the reaction. This also you can do it yourself. And balance the following basic ionic equations. So I will show you the equation and you can try to solve yourself. Okay, this is the balanced equation. You can write down and you can try to solve yourself. Matching type. Match the column 1 with the column 2 of the oxidation number. So you can match this is D. E is positive 6. So how to find the oxidation number I already explained at the start of this presentation. So you can go through it and solve yourself. Match the items in the column 1 with the relevant in the column 2. Ions having the positive charge, that is called cations. The sum of oxidation number of all atoms in a neutral element is 0. Okay, neutral molecule is 0. That is this. Oxidation number of the hydrogen ion. Because this is a single atom with a charge, so that is positive 1. Oxidation number of the fluorine, always negative 1. This one. Ions having negative charge, so called anions. Among the halogens, fluorine is the best oxidant. Fluorine is the most electronegative atom. Yes, fluorine is the most electronegative atom, and this also is true. In the reaction between potassium permanganate and the potassium iodide, permanganate ions act as an oxidizing agent. Oxidation state of the manganese changes from positive during the reactions. Okay, A is true, but R is false. So you can write the equation, find out yourself. The decomposition of the hydrogen peroxide to form water and oxygen is an example of the dispersion reaction. The oxygen of peroxide is in negative one oxidation state and is converted into zero. So you can write and yourself. So this is the correct answer. Redox couple is a combination of oxidized and reduced form. Okay, of a substance involved in the oxidation reduction. Okay, in the representation of this is the reduced couple. So both A and true, but this is not the correct explanation of the. Explain the relaxation on the basis of the electron transfer. The redox reactions in terms of the electron transfer. So you can go through these sections. Standard electrode pulse. So you can, I already showed you an example of how we can use this standard electrode potential to find out whether the reaction can occur or not. So based on that you can do it yourself. Because why does fluorine does not show disproportionation? That is, fluorine is a fixed oxidation state or oxidation number of negative one, so does not show disproportionation because highest electronegativity. So this also you can do for yourself. Find out the oxidation number of the following compound and these item in the increasing order of the oxidation number. Which oxidation state is not present? Okay, 37. So here you see here for the chlorine this is positive 7, positive 5, positive 1, positive 3. Okay, like that you can find out the oxidation number based on that various rules. So then you arrange in the increasing order. So negative 1, 0, 1, 3, 4. So plus 2 is not present. Plus 2 oxidation state. Minus 1 to plus 7. The plus 2 is not present. Okay, so which oxidation is not present? Plus 2 is not present. Which method can be used to find out the strength of the reductant oxidant in this solution? The example, so that is also given in the book. So you can go through this method, okay, to how to find the strength of the oxidant reduction. Okay. So when you solve the problems yourself, then only you will get familiar with various rules. In this chapter, the main thing is finding the oxidation number, balancing the redox reaction, and using the electrode potential to find out whether a reaction can occur or not.